So let me show you where you want to make sure you have this material that is reference materials. So you want a periodic table, and this is the periodic table with the polyatomic ions and the metals that have more than one possible charge. So this is all on one sheet, and you want to have this sheet handy. Now, one thing that Zoom doesn't do is it does not allow for multiple screens. So this screen, I'm going to trust that you guys have a periodic table in front of you. I'm grabbing mine right now. Have a periodic table. Why you need a periodic table? You need to use the periodic table for the family numbers. And so the periodic table for the family numbers will tell you the charge values of the elements that are in the A series. So the A series elements, 1A, 2A, 3A, those become +1, +2, or +3 ions. And then 5A, 6A, 7A, those become -3, -2, and -1 ions. Okay. You will also need these, the polyatomic ions, or you can memorize them. But these are also the chemical formulas of those polyatomic ions and the chemical names. So I had pointed out in lecture that these are names that end in ATE and ITE very commonly. And so the ATE and ITE endings indicate that there's oxygen in addition to another atom there. So nitrate means there's nitrogen plus oxygen, and that's how you have NO3. So you have a guess that when you have an ATE or ITE ending, it's going to be a polyatomic ion. And so polyatomic means many ions bonded together, and they're all acting as one unit. That's why they're all in parentheses, and they all have a positive or negative sign, and the majority of them have a negative sign. So you can see that they're really close, like nitrate and nitrite. So the ATE ending has one more oxygen than the ITE ending, or you could say it a different way, the ITE ending has one less oxygen than the ATE ending. Okay, so that's one is the periodic table. 2 is you want the polyatomic ions, and then 3, you want those that are called the polyvalent metals. And so those are the metals that form more than one ion. Okay, and so that is for the name. So you want to indicate the name. If it's chromium, it can be +2 or +3. So there's 2 versions of chromium. And if you have someone in class named Joe and you have 2 Joes, you need to use Joe W versus Joe X. And so this is the same thing. You have 2 versions of chromium ion. You need to distinguish between the chromium ion that's 2 versus 3 by using the Roman number 2 or the Roman number 3, and that's the charge value. So you need to use these 3 things, have them in front of you, have them in front of you now, have them in front of you when you're taking a quiz. And this is what we're going to be using a lot, specifically for ionic compounds. So let me switch over to a little bit of background. So writing some things down. So no video, but just some active work. So you want to use the periodic table for family numbers, the polyatomic ions. So that's the chemical formula is something in parentheses, and it's the chemical name. Okay, so you want to use those interchangeably. If you have the name of the polyatomic ion, you want to write the formula. Or if you have the formula, you want to be able to write the name. And then you're going to use the Roman numbers for those 5 that are chromium, copper, iron, lead, and tin. Okay, but not for zinc, which is always +2, or for silver, which is always +1. Okay, so the name of this would be zinc, and the name of that would be silver. And so you have all of that on that one page. So that is the one page at the bottom of modules in the Chem 9 Canvas. Okay, so you should be having all that. And so this process of chemical nomenclature, this is writing chemical formulas and writing chemical names. And so it starts with understanding that you have different compounds. So this is for different compounds. Don't want the eraser, want this one. Okay, so you have all different compounds. And there are two main categories of compounds. There are two main classifications of compounds. You have compounds that are ionic, and then you have compounds that are covalent. So how do you recognize an ionic compound versus a covalent compound? So the ionic compound is a metal plus a nonmetal. And you're talking about basically an element from the left side of the periodic table plus an element from the right side of the periodic table. So that's a metal plus a nonmetal, left side, right side. And so you have the metals tend to form a cation, that's a positive charge, and the nonmetals tend to form anions, those are negative charges. And so those two ions are attracted together. And so this forms the ionic compound when you have the positive charge with the negative charge. And the correct number of charges is where you end up using the crossover rule. So you end up using the crossover rule to write a chemical formula. And the crossover rule gives you the correct number of positive ions to negative ions so that you have no charge overall, that the charges will cancel out. Okay, this compares to a covalent compound. So covalent compounds are completely different. So covalent compounds are only nonmetals. So you might have two nonmetals, you might have three nonmetals, but you have two or more nonmetals, and there are no ions. So even though they are on the right side of the periodic table, they're not forming ions. These are electrons that are shared in bonds, and that's the definition of a covalent bond. Electrons being shared in bonds. For the ionic bond, electrons are transferred, but for the covalent bond, electrons are shared. And so you've got the covalent bond is you should have no ions. You should have no crossover rule. You should have nothing the same as ionic compounds, okay? And so that's the one thing to really understand is that when you have a compound, you first want to decide from the name, is it going to be ionic or covalent? And then you have to follow a different set of rules, whether you're writing the name or whether you're writing the covalent, whether you're writing the name or whether you're writing the formula. You have a different set of rules for ionic compounds and a different set of rules for covalent compounds. That's why there were two separate worksheets in that day's lecture, okay? So the covalent compounds use Greek prefixes. So remember those Greek prefixes, mono, di, tri, tetra, and so on. Those Greek prefixes tell you how many atoms there are. And so you don't have any crossover rule, but you do have the Greek prefixes. On the other side, on the flip side, for ionic compounds, you do use the crossover rule. You do have ions. Okay, so those are ions that have charge values. And you don't use any Greek prefixes if you're talking about an ionic compound. Okay, so there are two separate rules. In fact, I'm going to make this a big red dividing line. These guys have different rules than these guys, okay? Whether you're writing a chemical formula or a name. Okay, so let me move this down. All right, so let's see. Let's take a look at some examples. I'm going to actually take some examples from this 2.3 lecture here. So going back to here, the day we talked about naming was one lecture. I know it was a big lecture that, well, there was actually 2 days, a day and a half, but one of them that I covered most of the naming, writing chemical formulas and chemical names, was this one, 2.3. So I'm going back to here to pull some examples. So this is in questions for study and review. Write the chemical formula for the ionic compound that forms from aluminum and oxygen. Okay, so I'm going to take some examples here. just to get us started. And so this is writing the chemical formula for aluminum and oxygen. I need to write them down first, then I'll switch. And then you want to look at magnesium and oxygen. And then I want to look at aluminum and nitrogen. Okay, so now let's go back over here and see if you guys can follow along with me on this for those three examples. Okay, so I've got aluminum and oxygen. I've got magnesium and oxygen, and then I have aluminum and nitrogen. So how do you do this? Remember, you need to use the periodic table. So first you need to find the aluminum, which is element symbol Al. So aluminum is in family 3A. And so you would write that aluminum with a 3+. And then you need to find oxygen, which is the element symbol O. Everything in O is in family 6A, and everything in family 6A forms a -2 ion. Okay, so you want to write the element symbol and then the charge value as a superscript. And then you use the crossover rule. So these are ions and you're going to use the crossover rule. So what crosses over and down is the number. So the number 3 is no longer up or there and it crosses over and down. And then the number 2 is no longer up there and it crosses over and down. At the same time, you get rid of those plus and minus signs. So you end up with Al2 and then O3. Okay, and then what is this name? So that's the chemical formula. And the chemical name is writing the names of those individual ions. So the chemical name is aluminum. That's the name of the cation, is just the name of the element. And then the name of the anion, the negative charge, the O-2. Remember that anion name, you take the last few letters and it should have an IDE ending. Instead of being oxygen, it ends up as oxide, IDE. So that's the chemical name. Okay, so for magnesium and oxygen, magnesium is in family 2A. Okay, so you look for it, look at the top, and you find it's in 2A. This is magnesium with a +2 charge or 2+. And then the oxygen is the same, -2. So this ends up being Mg2 and an O2. And you can reduce that down. Anytime you can reduce those are the same common denominator. When you can divide by the same one number, both subscripts, then you should do that. And this becomes Mg1 and O1. Anytime you have ones, though, you get rid of those ones and it's just Mg and O. Okay, and then aluminum and nitrogen. So aluminum is in family 3A, it's still Al3+. And then nitrogen. So what's nitrogen in? That's in family 5A. And so everything in family 5A is a -3 ion. So that's -3. And then you're going to use the crossover rule. And so this ends up being, get rid of the plus and minus signs. So you have Al3N3. So what are you going to do with that? You can reduce that down, divide both of those by 3, and you have Al1N1. And then that would just be Al and N for the chemical formula. Okay, so let's fit that in. This is the chemical formula, and the chemical name of this would be just aluminum and nitride. Okay, so notice that Al2O3 is not named dialuminum trioxide. Notice it is not named dialuminum trioxide. Why is it not named that? Because, moving this up, those are Greek prefixes, and you don't get to use Greek prefixes when you are talking about ionic compounds. Greek prefixes are only for covalent compounds. So let's go back to this back up here. So the ionic compounds and covalent compounds are completely different. And you want to make sure you keep all of that completely separate. So stop yourself. If you are writing a Greek prefix, make sure you're talking about an ionic compound, or make sure you're talking about a covalent compound. And how do you know it's a covalent compound? If it is 2 or more nonmetals. And this is 2 or more, those are from the right side of the periodic table. So those are your covalent compounds, like having a nitrogen and an oxygen, or having carbon and oxygen. And so those will be represented in the chemical formula. You have the numbers of atoms, which you use with Greek prefixes. So let's take a look at one of those actually. So let's move down. So covalent compounds are totally different. And so covalent compounds are 2 or more nonmetals. And so you better not have any ions. So no ions, no Roman numbers. So this is an example, CO2. Okay, CO2, you know, is called carbon dioxide. So it's carbon, the first atom is 1. And when the first atom is 1, you don't use mono. But the second atom, when there's more than 1, you add on that Greek prefix. And that's the 2 is indicated the Greek prefix that there's 2 oxygens. Now, there's one thing is that you have the polyatomic ions are kind of hidden. They have some crossover. So they have, they start off, or I should say, they start off as some covalent compounds. And so an example, let me move this up. Let me move this up. Here's an example of CO3 2-. This is called carbonate ion. Oops. It's called carbonate ion. Let's write this correctly. So this is carbonate ion. You'll see it on your polyatomic ions list. So that's carbonate ion. It is not called carbon trioxide. Why is it not carbon trioxide? So it started off a covalent compound, but then the whole thing is in parentheses. And what it did was it became a polyatomic ion. It picked up 2 electrons. So these are not named as covalent compounds. They have their own names on the polyatomic ions list. So that's why you want to make sure you use the polyatomic ions list. And so this is an example where you have NO2, which is different from NO2 in parentheses minus. So NO2 is a covalent compound. So this is a covalent compound compared to NO2 minus, this is a polyatomic ion. How do you know it's a polyatomic ion? Because the whole thing has a negative charge. It's in parentheses with a negative charge. So when you write the name of this covalent compound, this one is called nitrogen dioxide. That's going to be different from this polyatomic ion, which when you look on the list, this is called nitrite. So those names are completely different. So make sure you're never crossing over into those territories. Okay, you guys have any questions? This page is a page that you are going to turn in. So you need to print this out. You can print it out and bubble it in as I go along, or you can just on a piece of paper, write number 1 is A, number 2 is A, number 3 is A, and that's what you can turn in. So let me show you again where this is. So this is here. Where is it? Here. Okay, so this is when you look to turn in the extra credit, you'll find it here. So this is extra credit polyatomic ions, and you'll download this, and it's a page, and I'm going to go over all those answers right now. And so this is something where you will see this quiz on my screen, and I'm going to go over these answers with you. So this is something you guys want to, you can do live and write down the answers as you're doing live. It'd be great if you start doing it live. The way to do this live is to basically log into, let me put this in the chat, to b.socrative.com. Okay, so open this in another window because this should save your answers, or you'll be able to go back to it so that you don't need to necessarily write this down. And then you're going to enter Chem 9 Wong. That's all one word. Let's look at a few more of these. Some of these, so I did these are easy, but when you are looking further down, let's look at some more of these. I'm gonna look at number, let's say 10. Number 10 is OH minus and Mg plus 2. And I want the chemical formula, okay? So to write the chemical formulas for some of these examples, I'm going to write down a few more of these. So that's number 10. This is Al3 plus and C2H3O2 minus. And then one more, I'm going to write CO3 2 minus and K plus. Okay, so using these examples, I'm going to go back to here. Okay, so I chose 3 off of the questions for study and review. And let's go back to here. So here's the thing, when writing the ionic compound chemical formula, a few things to remember is the cation always has to be written first. So that's the positive charge has to lead. And then you use the crossover rule. Okay. So let's write this for here. This is the cation has to be written first. So even though OH minus is first, listed first, you need to go ahead and write the cation Mg2 plus first. You know what? I'm going to move this down here. So Mg2 plus is written first. That's the positive charge has to be written first, even if it's not listed first. And then I'm going to write the negative charge, the anion next to it, OH minus. Then I want to use that crossover rule, and what crosses over and down is this 2. It's no longer up here, it's going to be down there. Then there's no number that crosses over and down. So at the same time, you get rid of the plus and minus signs, and you have Mg, and in parentheses, OH and a 2. So that 2 came over and down. So that's the chemical formula. And then how about the chemical name of this? This would be called magnesium, and don't call it don't call it anything except for hydroxide. Okay, so no di-tri or tetra, and don't call it oxygen hydrogen. This is the polyatomic ion hydroxide. That's what this OH minus is. So let's look at the next example. So writing the cation first is, let me move this down. I'm going to be Al. So this is Al3 plus. So that one is listed first. So I'm going to write it first because it's the positive charge, not because it's listed first. And then the next thing next to it is C2H3O2 minus. And this is on your polyatomic ions list. That's acetate. Okay, so what you have here is the crossover rule. The 3 crosses over and down, and then no number crosses over and down. So you end up with no number for the subscript of aluminum. And then you have C2H3O2 with a 3. So the name of this would be called aluminum. And then don't even think about any tri in there. But what is the name of this in the parentheses? That's on your polyatomic ions list. That's called acetate. Okay, and it stays in the parentheses because there's a 3 outside the parentheses. And then let's take a look at this one. Moving this down. I can't do this. Okay, there. So I need to move this down so I can write for these CO3 2 minus and K plus. I want to write the positive charge first. So the positive charge is K plus. And then the negative charge next to it, CO3 2 minus. Okay, always write the positive charge first. And then you're going to use the crossover rule. This has no number crossing over and down. And this has a 2 crossing over to here. So what you're going to end up with is K2 and then in parentheses CO3 and no number outside of the parentheses. That's okay. When you have nothing outside of the parentheses, you get rid of the parentheses. So this becomes K2 and CO3. That's different from these previous examples that had a number outside of the parentheses. When you have a number outside the parentheses, you can't get rid of them. When you do have no number outside the parentheses, so no subscript outside of the parentheses, you can get rid of the parentheses. Okay, so that's K2CO3 would be the correct chemical formula. And this chemical name is the name of the cation, that's called potassium, and then the name of the anion. Don't try calling it carbon trioxide. It's on the polyatomic ion list and it's called carbonate. And it's not going to be dipotassium because di is a Greek prefix and those only belong with covalent compounds. Okay. How do you guys feel about this? You should stop me if you have questions. You're feeling good? I'm going to go pick up a couple more examples then. Let me write them down. Okay, so let's take a look at some more examples. I'm going to choose from off of this one, number 13. So chemical names for these compounds. Actually, I'm going to go down to number, I'll do this one, KNO3 and NH4 2 SO4 and FeSO4. So I'm going to write the chemical names of these. Okay, so this one is writing the chemical names means for ionic compounds, you're writing the names of the ions. So you need to first figure out the ions. And then write the names of those ions. Okay, so figuring out the ions is basically the opposite of the crossover rule. So this is splitting this apart into the ions, which are K, and then I'm going to put a parentheses around NO3. So this is NO3 with the parentheses. So I'm going to split it apart into ions. And then I'm going to add a plus and a minus. The positive charge is always the first one. Okay. And then once I split it apart and then I added the plus and a minus, then I pick up any subscripts. Okay. I can't pick up any subscripts that are inside of the parentheses because you don't touch anything inside the parentheses. So subscript has to be outside of the parentheses, but anything inside the parentheses is a polyatomic ion and you don't get to touch any of those. So I don't have any subscripts to pick up. There's no numbers to pick up that are subscripts here that are outside the parentheses. So that means I just write the names of this. This is the potassium ion. And this is the nitrate ion on the polyatomic ions list. Okay. And so the next one is I'm going to take a look at this and I'm going to split it apart. This is in parentheses already. So I split this. I'm going to write NH4 in parentheses. And then also in parentheses, I'm going to write SO4. Keep that in parentheses by adding the parentheses first. Then I'm going to put a plus and a minus. And this 2 is a subscript that gets picked up. So this 2 right there, it's the only one that's outside of the parentheses. This gets picked up and where does it go? It goes up to here. Remember, things crossed over and down. So it goes up to here and it becomes the 2 up here above SO4. And that's good because this is the name of the ion on your polyatomic ions list called sulfate. And then this is the name, NH4 plus in parentheses, is the name of ammonium on your polyatomic ions list. Okay. And so let's take a look at this one. So this is Fe and SO4. Okay, so you want to split it apart. But before I split it apart, I'm going to put a parentheses around SO4. So it doesn't split apart into 3 different elements. Okay, so this is Fe and then SO4 in parentheses. Okay, put a plus and a minus. And then you pick up any subscripts. So this part again, pick up any subscripts. There's no that are subscripts outside of the parentheses. The problem is that iron has 2 possible ions. If you look on your polyatomic ions cheat sheet, iron is either +2 or +3, 2 plus or 3 plus. Well, this is not Fe1. Okay, so, and also sulfate is on your polyatomic ions list. Sulfate is SO4 2 minus. It is not just SO4 minus. So there's a problem here, is that none of these ions are correct. So these are not correct ions, but you can multiply both ion charges by 2. So this will become, let's switch this out, move this up a little bit, Fe 2 plus, and in parentheses, SO4 2 minus. And now you have a correct ion charge for iron, and you have a correct ion charge for sulfate. So the name of this one is iron with a Roman number 2. And the name of this one is sulfate on the polyatomic ions list. Okay, I'm going to go get a couple more examples here. Okay, so I'm going to get a couple more examples. Let's see. Let's get these, the chemical. So what did I do? Chemical names. Let's do some chemical formulas. So this is another few more examples from the same questions for study and review. Sodium hypochlorite, magnesium carbonate, and I'm going to add in some more of these. So this is dinitrogen monoxide and calcium hydroxide. Okay, so switching back over so you can see what I just chose from my examples. Okay, oh, you guys were already on that. So I've got sodium hypochlorite. So this is an ionic compound. Okay, the ionic compound means you need to write the ions and use the crossover rule. Okay, crossing over the charges, but you need those charges first. So sodium hypochlorite means you need the ion for sodium, which is in family 1A, so that's going to be Na+. And then hypochlorite, where are you going to find that? You're going to find that on the polyatomic ions list. It is ClO minus. So put it in parentheses, ClO, and then minus. So you want to cross over and down, no numbers. And so this will just end up being Na and ClO, getting rid of the parentheses. Okay. For the next one, you have magnesium and carbonate. So magnesium is in family 2A, which means you would write magnesium with a +2 charge. And then carbonate is on the polyatomic ions list. So you want to look up that polyatomic ion. It is CO3 in parentheses. and then 2 minus. Now you do have numbers crossing over and down this time. This is going to be a 2 down here and a 2 down here. And at the same time, this Mg2 and CO3 2 can be reduced down to just Mg and CO3. So you can reduce down those 2's and you can also get rid of the parentheses. So that would be the correct chemical formula. For the next example I wrote, you have dinitrogen monoxide. Now notice this di. That's a Greek prefix. So that Greek prefix means you're looking at a covalent compound. A covalent compound means no ions. So don't write any ions and don't use the crossover rule, okay? So that di is a Greek prefix. And the other way you would notice this is a covalent compound, not just from the Greek prefix, is that there are 2 nonmetals. So you have nitrogen, which is a nonmetal. It's to the right of the stair-step line. You also have oxygen. That's also a nonmetal. It's to the right of the stair-step line. So when you have the covalent compounds, you don't write no ions and you don't use the crossover rule. All you do is you use the Greek prefixes to indicate how many as a subscript. Okay, so that's what that di means. It means that there's 2 of these guys, 2 nitrogens. So this is N2. And then this mono means that there's 1 of these guys, which is oxygen. So just 1 O. So N2O would be the chemical formula of that one. Okay, so for the next example, calcium hydroxide, well, now you're back into the ionic compound territory. I don't see any Greek prefixes, but I do see this hydroxide, which is on the polyatomic ions list. So this would be calcium, which is also a metal. So anytime you have a metal that's on the left side of the periodic table, it's going to be metal plus non-metal. That's going to be an ionic compound. So for the ionic compounds, those are metal plus non-metal, remember? So left side plus right side. And so what should tip you off is anything in family 1A, 2A, or 3A. If that's the first element, is 1A, 2A, or 3A, that's a metal, and you're talking about an ionic compound, which means write the ions and use the crossover rule. So this is going to be calcium, which is a 2+, and hydroxide, which is on the polyatomic ion list, OH-. So then you are going to cross over and down. Let me move this. You want to cross over and down this 2. And this is not going to be Ca. It's going to be a Ca with no plus sign, and in parentheses, OH, and then a 2 down there. And that would be the chemical formula. The Quizlet is different. It is not unlimited attempts. It is also not unlimited time. So you get exactly 2 attempts, and you'll have 15 minutes once you start it. So make sure you're ready. Make sure you have everything in front of you, that you have the cheat sheet with the periodic table, the polyatomic ions, and the metal ions. And you'll have just the 15 minutes, but it's worth up to 5 extra credit points. You can review all of these lecture videos from the sessions that covered nomenclature, writing chemical names and writing chemical formulas. But this is something that you're going to want to start, and you do have time until Sunday. But I'm going to go through the questions that I have,